Hello everyone. Friends, we have already discussed the concept of limits and continuity in two episodes, that is part 1 and part 2 also. So in part 1 we learned some properties of limits and some examples regarding the concept. So in part 2 we discussed some shortcut methods, that is method 1 and method 2. Coming to the part 3, this is the last part of this concept. So here also we have to discuss some other shortcut methods, that is method 3 and method 4. So now see the shortcut method 3. So in this method, so the limit form definitely is in the form of either quadratic equation or binomial expression. Quadratic equation means we know ax square plus bx plus c is equal to 0. So this equation is called quadratic equation. So binomial expression, so here is the same form, that is the constant is also there. So that means a to the power of x to the power of 4 plus a to the power of x cube plus a to the power of x square plus and so on, a to the power of x power n minus 1. So this is the binomial expression. So the limit term is in the form of either quadratic equation or binomial expression. So this shortcut method 3 is very useful to solve the limit function. So if the limit, suppose let us see the example. So limit x tends to infinity. So here the x tends to infinity must be the same in this method. So the numerator term is 2x square plus 3x plus 1 by 3x cube plus 2x square plus x. So here the limit x tends to infinity, the numerator term and denominator term is in the form of quadratic or binomial expressions. So then we can directly give the answer for this question by comparing the numerator term and denominator term. So how to comparing the numerator term and denominator term? So here the numerator term, the coefficient, highest coefficient of numerator term, here 2 is the highest coefficient power of the numerator. So coming to the denominator, what is the highest power? So the highest power is 3, because of here it is the x cube. So x cube is greater than the x square and x. So this is the highest power in the denominator and this is the highest power in the numerator. Now we have to comparing the highest power in the numerator and the highest power in the denominator. If the highest power in the numerator is greater than the denominator, so it tends to infinity is the answer for this question. So in case 2, if the numerator power is less than the denominator, it tends to 0. So there is another case also, that is the possible case is equal, that is numerator power is equal to denominator power. If suppose here this is the highest power is 2, suppose here it is also the highest power is 2. So then what will happen? The numerator highest power and denominator highest power is to be equal. So we are not considering the other powers of the equations. So 3x power 1 we are not considering, 2x square not considering, x power 1 not considering. We are considering only the highest powers in the equations. So whenever the numerator term is equal to denominator term, the formula for this coefficient of highest power in numerator by coefficient of highest power in denominator. So this is the formula for this case. So coming to this example, here the numerator power is 2 and the denominator power is 3. So 2 is less than 3. So less than means numerator power is less than denominator, then it tends to 0. So 0 is the right answer for this question. Now we have to check whether it is a x tends to infinity or not. If x tends to infinity, then only these 3 cases are applicable, otherwise it is not applicable. So let us see some of the examples regarding this third method. So these are the problems regarding the concept. So limit x tends to infinity, x to the power of 4 minus 3x square plus 1 by x square plus 5. Now we have to comparing the numerator coefficient, numerator power, and as well as denominator power. So the highest power in the numerator is 4 and the highest power in the denominator is 2. So by comparing the numerator and denominator, 4 is greater than 2. 4 is greater than 2. So if the numerator power is greater than denominator power, it tends to infinity. So case 1 is applicable. So coming to the second question. So in second question, the highest power in the numerator is 3. So not this 3. So here x, of course, so many people, the highest power in this numerator is simply tell as a 6. But here it is the square root of x power 6. So square root of x power 6 is the highest power. So it can be written as a x power 6 whole to the power of 1 by 2, that is equal to x cube. So the highest power is 3. The highest power in this term is 3. So 3 is by comparing the numerator power and denominator power. So coming to the denominator, the highest power is 5. So 3 is less than 5. 3 is less than 5. So it tends to 0. This is the second case. So coming to the next one, here the highest power is 4 and the highest power in the denominator is 5. So numerator power 4 and denominator power 5. So 4 is less than 5. It is also tends to 0. Second case is applicable for this third question and second question. Now coming to the last one, limit x tends to infinity 5x cube plus 7x plus 4 by square root of 3x plus 8x square plus 7x to the power of 6. So here the highest power in the numerator is 3. Highest power in the numerator is 3 and highest power in the denominator. So not x power 6. Here the highest power is x square root of x power 6. So square root of x power 6 means x cube. So highest power is 3. So denominator power is 3. Here 3 numerator power 3 and denominator power 3 is equal to same. So the third case is applicable. The third case is whenever the numerator highest power is equal to denominator highest power. So the third case formula is coefficient of highest power in the numerator by coefficient of highest power in the denominator. So here it is the highest power in the numerator. So the coefficient of the highest power in the numerator is become a 5 and the coefficient of highest power in the denominator is become a root 7. So this is the coefficients. These are the coefficients and these are the power values. So I am written as a 5 by root 7 is the answer. So this is the coefficient of highest power in the numerator. Root 7 is the coefficient of highest power in the denominator. So 5 by root 7 is the right answer for this question. So just by comparing the numerator and denominator values, we can simply write the whether it is infinity or 0 and whatever the value. Three cases are applicable. Remember one thing, here x tends to infinity for all the questions must be, we have to check. And as well as the limit forms must be the either quadratic equations or binomial forms, not sin x or log x. So these terms are not applicable for this method. Okay friends? So let us see the another shortcut method, that is the method 4. This is very important method in this limits and continuity concept. Method 4. So it is very funny also. So I can explain. Limit x tends to anything. So anything means either infinity, 0, 2, 3, whatever the value. So limit x tends to 0. So here this is the tree. So here it is the monkey. Suppose the limit x tends to 0. Suppose the problem is the limit x tends to 0. So x square. Suppose limit x tends to 0, x square. So here means x square means in the place of tree, here it is the x. In the place of monkey it is the 2. Just power of the x. So that is the tree on the monkey. Monkey on the tree. Sorry, monkey on the tree. So that is equal to e power limit x tends to anything, whatever. Suppose here it is the infinity and here it is also the same infinity. Suppose here it is the 0 and here it is also the same 0. Tree cut down. Monkey comes down. So how to remember this form? So here limit x tends to anything, here also e power limit x tends to anything. If 3 minus 1, that means, so remember, cut down the tree. Cut down the tree means 3 minus 1. So suppose we can cut down the tree. So monkey comes down. So that's why, so the monkey place is like product of this term. So this is the logic for remembering this term. So now see the problems regarding this form. So this is very useful and important also. Most of the problems are related to this technique. So let us see how to solve the problems regarding this method. So let us see the first problem. Limit x tends to infinity, x plus 5 by x minus 1 whole to the power of x. So by comparing the monkey technique, so here the tree value is x plus 5 by x minus 1. So and the monkey value is x. So the form is, so whatever the limit tends to either infinity or 0. So the formula is limit, e power limit x tends to, here it is the infinity, so that's why I have written as infinity. So e power limit x tends to infinity. So cut down the tree. The first point we have to remember, cut down the tree. So cut down the tree means x plus 5 by x minus 1 minus 1. Cut down the tree. So what will happen whenever we cut down the tree? The monkey comes down. So here the monkey value is x. So into x. So this is the form. Now we can simplify this equation. So this is equal to e power limit x tends to infinity. So x plus 5 taking LCM, x minus 1. So minus x plus 1 into x. So plus x minus x cancel each other. So finally the remaining term is e power limit x tends to infinity. So 6x by x minus 1. So now we have to simplify. So here the numerator term is the x and denominator is also includes with the x. Now just comparing the coefficient of the x in the numerator and coefficient of the x in the denominator. So here the coefficient of the x is 6. Here the coefficient of the x is 1. Coefficient of the x is 1. So then we can simply write e power 6 by 1. Numerator coefficient is 6, denominator coefficient is 1. So that is equal to e power 6. Whenever x tends to infinity, this form is applicable. So e power 6 is the right answer for this question. Now see the another problem. Here also the tree place 1 plus 5x square by 1 plus 3x square and 1 by x square is in the monkey place. So same, e power limit x tends to, here it is the 0, that's why I am going to write 0. Limit x tends to 0. So cut down the tree. So cut down the tree means 1 plus 5x square by 1 plus 3x square minus 1. So what will happen whenever we cut down the tree? The monkey comes down. So here the monkey place is 1 by x square. So into 1 by x square. Now take the LCM. So e power limit x tends to 0. 1 plus 5x square minus 1 minus 3x square by 1 plus 3x square into 1 by x square. So here plus 1 minus 1 cancel each other. So 5x square minus 3x square, that is the 2x square. that is the 2x square. X square cancel. Finally the numerator term is 2. So e power limit x tends to 0, 2 by 1 plus 3 x square. The denominator term is 1 plus 3 x square. Now substitute the x tends to 0. So x tends to 0 means suppose here x place in the place of x we can substitute 0. So 0 into 3 0. So finally 2 by 1 that is equal to 2. So the answer is e power 2. So by simply you can make the 2 to 3 steps, we get the answer for this question. Now see the third problem. Limit x tends to infinity, x plus 6 by x plus 1 whole to the power of x plus 4. Here the e power limit x tends to infinity. So cut down the tree, x plus 6 by x plus 1 minus 1. So monkey comes down, in the monkey place the x plus 4. So into x plus 4. So that is equal to e power limit x tends to infinity. So x plus 6 minus x minus 1 by x plus 1 taking LCM into x plus 4. So minus x plus x cancel each other. So 6 minus 1 5. So 5x plus 4 by x plus 1. So this is equal to e power limit x tends to infinity 5x plus 20 by x plus 1. So whenever x tends to infinity, comparing the coefficient of x in the numerator and divided by coefficient of the x in denominator x. So here the coefficient is 1. So numerator coefficient is 5. So the answer is e power 5. So let's see the limit x tends to 0, a power x plus b power x plus c power x by 3 whole to the power of 1 by x. So this question is asked in MSET 2019. So here we have to apply the same method. So here this is the a power x plus b power x plus c power x by 3 is in the place of tree and 1 by x is in the place of monkey. So we can cut down the tree. So e power limit x tends to infinity, sorry x tends to 0, a power x plus b power x plus c power x by 3 minus 1 into 1 by x. So taking LCM, e power limit x tends to 0, a power x plus b power x plus c power x minus 3 by 3 into 1 by x. So this is equal to e power limit x tends to 0. So we can simplify these terms. So a power, so this minus 3 is rewritten as a minus 1 minus 1 minus 1. We can divide the minus 3 into 3 parts. So a power x minus 1 plus b power x minus 1 plus c power x minus 1 by, so this 1 by x comes to denominator x into 1 by 3. So this 3 goes to separate part. So here by observing the limit x tends to 0, a power x minus 1 by x. So we have a property for that. Limit x tends to 0, a power x minus 1 by x is equal to log a. So here also same. So by applying the formula log a plus log b, b power x minus 1 by x plus log c into 1 by 3. So by applying the properties of the logarithm, so log a plus log b plus log c, that is e power 1 by 3 log a b c. So that is equal to, so 1 by 3 into log a b c, again we can apply the log properties, e power log a b c whole to the power of 1 by 3. So finally e power log cancel. So the answer is becomes ABC whole to the power of 1 by 3. So this is the answer. So whenever we know the properties very well, either limit properties or logarithmic properties or trigonometric properties, we can simply solving the limit functions, whatever the problem. So by knowing the trigonometric properties, logarithmic properties, limit properties, some shortcut tricks, we can easily solve the each and every question regarding this concept. I want to give a practice question for you regarding this concept. So if you get the answer, just give the answer on the comment box. So try to solve this question by using this monkey on the tree technique. So we can simply get the answer for this question. So thank you for watching. So for more updates, stay tuned. So meet you soon.